Vectors in a plane. This video is all about how to draw vectors in a plane. So we all know how to draw a point in a plane. If I give you a point 2, 5, we know the x is 2 and the y is 5. You can just go over 2, up 5. It's actually very, very similar with vectors. So first, notation. So this is one of the general notations for vectors. It kind of looks like a coordinate point, but with the x on top and the y on bottom. That's the way it's going to work. The top number is essentially like your x. The bottom number is essentially like your y. So if I see a vector, in this case OP, that's going from O to P, where O is the origin, my x value is 2, my y value is 5, and we'll graph it like the same thing. So you go over 2 on your x, and 5 on your y. Now, since this is a vector, and we're starting from O, we got to start from O, and just draw the line from O to P. Another way to write this is in component form. That's with the i's and j's. So all this means, I lets you know, I is what we call a unit vector in the x direction, and j is what we call a unit vector in the y direction. It's this notation. So if when I see 2i plus 5j, I know they want me to go 2 in the x and 5 in the y. So I know that's the same thing as saying this. Or if you want to write it a different way, you can write it like this. Right? So let's know, oh, okay, in this vector, we're going to go 2 in our x. In this vector, we'll go 5 in the y. So it's just all about notation. And that's what this says here. If you see this, it's the exact same thing as seeing that. Let's do an example or two of how to draw a vector. So it's first vector A. So I want to go 3, 2. So all we're going to do there is go 3 my x. That's what this point is, like your x value. And go 2 my y. So right there. Right, that's the point 3, 2. I want to draw the vector. So if we want to go A, all we do is start from the origin and go to that point. That'll be the vector A, also known as 3, 2. And this should have been written. This form right here should have been written vertically. That right, it's like right there's a point. Right here's a vector. Slight difference, but it means the same thing. And if I want to draw 4i plus j, a lot of times I rewrite it. I just like it better when it's in the other form. That's 4 and 1, right? The coefficient of j is 1. Works either way though. Here's x, here's y. We'll go to 4 on our x and 1 on my y. And then it's the point from the origin to there is the vector b. That's the idea. All vectors in the plane can be described in terms of I and j vectors. So like here, these two vectors in the plane, they don't have an origin, but you can still write the same way. So the way you write it, you find where you start and where you end, and you find the slope. Because the component form of a vector is also just the slope. So we're going to find 2 points. Now, very important here, I was going to circle the arrow. It's not like a normal slope where you go left to right. Well, in this case, you actually have to go from the tail to the tip. So wherever the point is, we're going to go from the tail to the tip. And just keep in mind how much you're moving your x and how much you're moving your y. So in this case, my x, I moved 3, and my y, I moved down 1 to -1. So I could write this vector like 3 and -1. Because again, on my x, I moved positive 3, and my y moved down 1. Or you could write in component form 3i minus 1j, or just j, like you see right here. I can do the same thing on this side. Now again, when you do vectors, this is why it's not exactly like slope, but essentially slope, because you got to figure out where the tail and the tip is. You're going from the tail to the tip. So if we're not going to go left to right, you go from tail to tip. So I have to go over, I have to go with left 4, which is a negative, like a normal XY chart. Plus, minus, right? Going right is positive, going up is positive, going left or down is negative. So we went left, negative, we're going up, positive 3. Now keep in mind, your x's, it's all about which direction. So my x, I went left 4, so b could be written as -4 my x and a positive 3 my y, or -4i plus 3j. Alright, so the two forms of writing a vector. Now what it says here is two vectors are equal if their components are equal. So if we have two vectors in space, if we find the same component form, then they're equal. So write OA and CB in component form. So let's do OA first. So I start here and I'm going to there. So we're going to go over 3 and up 1. So I could write A as 3 my x, 1 my y, or 3i plus j. I can do the same thing to CB right here. So I'm going to go over 3 and up 1. So you can write CB as 3, 1, or 3i plus j. And those two will be equal vectors. They're the exact same vector. They're the exact same component form. It's essentially the same slope. And that's the video.